Have you ever stopped for a second and wondered what keeps the internet alive? Not your phone, not your laptop, but the giant hidden buildings working silently behind everything you do online. Every social media post, every online payment, every movie you stream, every photo stored in the cloud, all of it passes through massive data centers running 24/7. But here's the crazy part. The biggest problem inside those buildings is not power, it is heat. A single human sitting in a chair gives off around 400 to 450 BTU per hour, but one server rack inside a data center can produce 17,000 to more than 102,000 BTU every single hour. That is like placing industrial heaters inside a sealed room and never turning them off. If cooling fails for even a few minutes, temperatures can rise fast enough to destroy millions of dollars in equipment. Entire websites can go offline. Financial systems can crash. Cloud services can disappear instantly. And because modern AI systems, cryptocurrency mining, and cloud computing are growing faster than ever, these cooling systems are now being pushed to their absolute limits. So how do companies stop these machines from overheating? Why are some data centers pumping cold air from beneath the floor, while others are starting to cool computers with liquid instead of air? And why are traditional cooling systems slowly becoming outdated? Before we dive in, make sure to like the video, subscribe to the channel, and turn on notifications, because what you're about to see is the hidden engineering world powering the modern internet. In this video, we are uncovering how data center HVAC systems actually work. From cold aisles and hot aisles to liquid cooling systems so advanced they almost feel futuristic. But there is one cooling technology changing the industry faster than anyone expected, and surprisingly, it does not rely on traditional air conditioning at all. So what is it, and why are the world's largest tech companies rushing toward it? Stay with us, because the answer begins in the next part. To understand why data centers need such advanced cooling systems, we first need to understand what is actually happening inside these facilities. At first glance, a data center may not look very impressive. Just long rows of black cabinets lined up side by side. But behind those metal doors are some of the most powerful computing systems on Earth. Inside each rack are servers, routers, switches, storage systems, and networking equipment stacked vertically from bottom to top. Most racks stand around 7 feet tall, or about 2.1 meters. These machines process enormous amounts of information every second. Every Google search, every social media notification, every online purchase, every cloud backup, all move through systems like these. And every one of those systems generates heat. A normal person sitting quietly produces around 400 BTU per hour. But a single server rack can generate anywhere from 17,000 to over 102,000 BTU every hour. That amount of heat is massive. Now imagine hundreds or even thousands of those racks operating together inside one building without ever shutting down. Because unlike office buildings, data centers never sleep. They run 24/7, 365 days a year, day and night, weekends, holidays, even during storms and emergencies. That constant operation creates a non-stop heat load that must be removed continuously. If temperatures rise too high, servers can slow down, hardware can fail, and entire systems can crash. In the early days of data centers, cooling systems were much simpler. Cold air was pushed into the room, and engineers hoped enough of it would reach the servers before mixing with hot exhaust air. At the time, that strategy worked reasonably well, but then technology changed. Servers became smaller, more powerful, and dramatically denser. A single rack could suddenly consume huge amounts of electricity, producing far more heat in a much smaller space. Traditional room cooling systems started struggling to keep up, and this forced engineers to rethink airflow completely. That is when the concept of hot aisles and cold aisles became one of the most important designs in modern data centers. Here's how it works. The front of every server rack faces the cold aisle. That side receives cold supply air directly from the cooling system. The servers pull in that cold air, absorb heat internally, then push the hot exhaust air out the back of the rack into the hot aisle. Simple idea, but incredibly effective. The real challenge is stopping those two air streams from mixing together, because the moment hot air recirculates back into the front of a rack, cooling efficiency drops immediately. Some servers begin overheating, while others remain cool. These dangerous temperature zones are known as hotspots. To improve airflow, engineers introduced raised floor systems. instead of placing server racks directly on the building floor. The entire data center floor is elevated several inches above the structure underneath, sometimes 6 inches, sometimes 30 inches. That empty space below becomes a giant air chamber called an underfloor plenum. Cold air is pumped beneath the floor, then released upward through perforated floor tiles placed only where cooling is needed. The cold air rises directly into the cold aisle, enters the servers, absorbs heat, then exits into the hot aisle before returning back to the HVAC cooling units. This design improved cooling dramatically, but there was still a major problem. The room itself remained mostly open. Hot air could still drift over the racks, mixing with the cold supply air. And as data centers grew larger, this inefficiency became more serious. So engineers developed something called containment systems. Instead of allowing hot and cold air to move freely throughout the room, physical barriers were added to separate them completely. In a cold aisle containment system, also called CAC, the cold aisle is enclosed using doors and ceiling panels. Cold air is trapped exactly where servers need it most. In a hot aisle containment system, or HAC, the hot exhaust air is enclosed instead, then removed directly back to the cooling equipment. Both methods dramatically improve efficiency because hot and cold air no longer mix together. Servers receive more stable temperatures, cooling units work less, and energy consumption drops significantly. But even these advanced airflow systems began reaching their limits. Because modern workloads, especially AI computing and cryptocurrency mining, generate unbelievable heat densities, some server racks now produce so much heat that ordinary air cooling simply cannot remove it fast enough anymore. And that is where the industry began turning towards something that once sounded impossible: liquid cooling at first. The idea feels dangerous. Computers and liquids normally do not mix well. But surprisingly, liquid transfers heat far better than air. In fact, liquid can carry several times more thermal energy than the same amount of air. That makes liquid cooling incredibly effective for high-density computing. Some systems use liquid-cooled heat exchangers built directly into the rack. Small fans move hot air across cooling coils filled with cold liquid, removing heat almost instantly. Other designs place heat exchangers directly on the rear doors of the racks, capturing heat the moment it exits the servers. And then there are immersion cooling systems. Entire servers are submerged inside special non-conductive liquids designed specifically to absorb heat. No traditional airflow, no massive fans, just direct thermal transfer into engineered cooling fluids. It sounds futuristic, but many companies are already investing heavily into this technology, because the future of computing is producing more heat than traditional cooling systems were ever designed to handle. But cooling the servers themselves is only part of the story. How do these facilities actually move all that heat outside the building? What machines power these giant cooling systems? And why are some companies abandoning traditional air conditioning completely? That is where systems like CRAC units, CRAH units, and CDU technology enter the picture. And once you understand how those systems work together, you realize something fascinating. Modern data centers are not just computer buildings anymore. They are giant thermal engineering systems built entirely around controlling heat. As data centers became more powerful, engineers quickly realized something important. Traditional room cooling systems were starting to reach their limits. Older server environments produced manageable amounts of heat, but modern AI systems, cloud computing, streaming platforms, and cryptocurrency mining changed everything. Today, some server racks generate so much heat that ordinary airflow alone is no longer enough. For years, the most common cooling systems inside data centers were CRAC units and CRAH units. They may look similar from the outside, but they work differently. A CRAC unit, short for computer room air conditioner, uses DX cooling. Refrigerant absorbs heat from the air, then transfers that heat outside through condenser systems. A CRAH unit, or computer room air handler, uses chilled water flowing through cooling coils instead of refrigerant. That chilled water is produced by large chillers elsewhere in the facility. Both systems usually work with raised floor airflow designs. Cold air moves beneath the floor, rises through perforated tiles, enters the server racks, absorbs heat, then exits into the hot aisle before returning back to the cooling units. For years, this became the standard design, But as server densities increased, engineers started noticing major inefficiencies. Cold air had to travel too far, energy usage increased, and hot air still mixed with cold air inside the room. That led to one important idea. Instead of cooling the entire room, why not bring cooling directly to the heat source itself? And that idea created in-row cooling systems. Instead of placing cooling units around the room, these systems are installed directly between server racks, much closer to the actual heat source. They pull hot air from the hot aisle, cool it immediately, then push cold air back into the cold aisle. Because airflow paths are shorter, cooling becomes more efficient, while fan energy usage drops significantly. And this matters because not every rack produces the same amount of heat. One row may contain simple networking equipment, while another row contains powerful AI processors generating enormous thermal loads. But even advanced airflow systems have limits. Air simply cannot remove enough heat fast enough for some modern workloads. And that is exactly why liquid cooling is becoming one of the biggest trends in the industry. Liquid transfers heat far more efficiently than air. Some liquid cooling systems can remove several times more heat than traditional airflow systems. One method uses rear-door heat exchangers mounted behind server racks. As hot air exits the servers, liquid-cooled coils absorb the heat almost instantly. Other systems place cooling coils directly inside the racks themselves. And then there is immersion cooling, one of the most futuristic technologies being developed today. Instead of using airflow, entire servers are submerged inside specially engineered dielectric liquids. These fluids do not conduct electricity, allowing electronics to operate safely while heat transfers directly into the liquid. No massive airflow systems, no giant fan walls, just direct liquid heat transfer. But behind these liquid cooling systems, there's another critical component: the CDU, or Cooling Distribution Unit. The CDU acts like the control center for liquid cooling infrastructure. It separates the sensitive liquids circulating inside the server racks from the outdoor cooling systems like cooling towers or dry coolers. Inside the CDU, heat exchangers and pumps continuously move heat away from the servers while keeping the systems isolated for safety and reliability. One of the biggest advantages of these systems is efficiency. Many facilities can reduce their dependence on traditional refrigeration equipment, lowering electricity usage dramatically. And today, that matters more than ever, because AI computing, cloud storage, video streaming, and cryptocurrency mining are all increasing global demand for data centers. That means one thing: the future of data centers is no longer just about computing power. It is about controlling heat as efficiently as possible, and behind every website, every cloud service, and every AI system, there is one hidden battle happening every second: the battle against heat. So the next time you upload a photo, stream a movie, or open a social media app, remember this: behind the internet we use every day are massive data centers fighting an endless battle against heat. From cold aisles and hot aisles to CRAC units, CRAH systems, liquid cooling, and futuristic immersion technology, the world of data center cooling is evolving faster than ever before. And as AI computing continues growing, cooling technology may become just as important as the computers themselves. If you enjoyed this video, make sure to like, subscribe, and turn on notifications, because we have many more deep technology breakdowns coming soon. And now we want to hear from you. Which cooling system surprised you the most? Traditional air cooling or futuristic liquid cooling? Do you think immersion cooling is truly the future, or will airflow systems continue evolving? Leave your thoughts down in the comments below. And if there is another technology topic you want us to cover next, comment it down below as well. Your comments genuinely help guide future videos, and your support motivates us to keep creating more content like this for the channel.